All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to be doing another study stream. Um, we are going to be carrying on learning about building neural networks, building and hopefully also training neural networks with PyTorch. I was supposed to start the stream an hour ago, but I kind of got distracted because, okay, so yesterday, or I think the day before, I think, I kind of got interested in checking out the various methods that scikit-learn has to offer. Because I found this section. Okay, so real quick, let's just look at scikit-learn for a little bit, and then we're going to go into the neural network stuff. Or rather, then we're going to go into the PyTorch stuff, which is going to be the neural network stuff. So in scikit-learn, they have the user guide, which is divided into these sections. Hold on. Let me see if the user guide gives like a list of it. Otherwise, I can just show it to you from this side, but like it's better if I can show it like this. Oh, this is not collapsed, which is fine. It's great that it's expanded. Honestly, if I was going through, if I was looking at this index list under any other circumstances where like I was actually looking for specific like information and stuff, then I would have preferred the expanded version. Anyways, what I was trying to show was this. So in the user guide, they have these sections. It's divided up into these sections, and each of these sections has like a subsection. So keeping the others aside, currently, I'm more interested in these two, supervised learning and unsupervised learning, but a lot more interested in unsupervised learning because for those of you who don't know, supervised learning is usually done on labeled data, whereas unsupervised learning is done on data that has no labels. So you have to use various algorithms to sort of figure out a pattern, figure out a relationship between the different data or the different data points, I should say, or the different observations, I guess. I don't know. The different data points, the different variables, that's the word. You have to use various methods to find relationships and patterns between the different variables in the data. So that's kind of interesting to me. A lot more interesting than supervised learning, but there are a lot. There are well, not a lot. There are a couple of methods even in supervised learning that I'm interested in. But something that caught my eye was this clustering. And there's a couple of different clustering methods. The whole idea with clustering is that given a specific data set, you are able to, or the algorithm rather, depending on which algorithm you choose, it is able to divide up the data into various clusters. So it's able to group the data into different types of categories. And I'm really interested in that because not only clustering, but also a couple of other methods that are mentioned here. I'm interested in using these methods or trying to use these methods to find patterns in data. So I've been I've been like on the side while learning PyTorch. I've also been looking into this because previously I tried to. So I'm interested in something called exploratory data analysis, or EDA, and I'd been approaching it from a different angle. I was trying to find various topics like clustering. And for example, I would find a specific type of clustering, let's say, for example, k-means clustering. And then I would try and look it up and try and find information on it, which would usually mean me going to Wikipedia to get the information, right? And then I would kind of just get stuck there because there would be lots of information. But I feel like approaching it through scikit-learn is gonna give me a more gentler introduction. So I kind of wanna get into this as well. I wanna try using these various methods to find patterns in data sets. For now, I'm aiming for one of the free data sets which is available, which is a data set called Iris, which I don't know if I've got the information right, but I believe this is a data set that has information on various flowers, I think. Hold on, let me see what it says. This, because the iris data set has been mentioned in a bunch of different like machine learning related stuff, machine learning and even deep learning related tutorials. The iris data set has been mentioned there. Oh yeah, okay, so it mentions here the iris flower data set, or Fisher's iris data set is a multivariate data set used and made famous by British statistician. Hold on, statistician. Okay, this word, I fucking hate this word. I like statistics. I hate saying statistics because the word is not easy to say. But anyways, it's uh, by the British statistician and biologist Ronald Fisher in his 1936 paper. The use of multiple measurements and taxonomic problems as an example of linear discriminant analysis. The use of multiple Oh, that's the name of the paper. The use of multiple measurements in taxonomic problems as an example of linear discriminant analysis. It is sometimes called Anderson's iris dataset uh, because Edgar Anderson collected. Okay, hold on. This is great. The history on it is great, but I'm trying to get like the information on the dataset. Okay, the dataset consists of 50 samples from each of the three species of iris. Four features were measured from each sample. The length and width of the sepals and petals in centimeters. Based on the combination of these four features, Fisher developed a linear discriminant model to distinguish each species. Fisher's paper was published in so and so. Okay. Right, so this is one of the data sets. And then there's a couple of other data sets as well. Honestly, there's a bunch of different types of data sets that I can use, and I'm kind of interested in using many of those data sets to try and find patterns using these methods. I want to see what types of patterns I'm going to be able to find. More specifically, for the time being, I want to try and apply this to sales data sets. I need to see if I'm able to get sales data sets, free sales data sets. Let me put that out there. I want to see if I can get free sales data sets from somewhere, or even like fake free ones. I don't mind as long as they represent, as long as they're closely related to real world data. Like as long as they look like real world data, I don't care if it is actually accurate or not. Um, you know what? I'm curious. Let me Google it. Free sales data set. Sample sales data. So there's a thing on Kaggle, and there's a website called data.world. I'll look into this website later. For now, let me look at Kaggle. Somebody has provided a thing here. And on Google, they just have a section. Okay, that's interesting. This is for something called catalog.data.gov, or this is from something called catalog.data.gov. Then there's another one from data.world, and then there's another one from data. Okay, all right. That's interesting. What is data.world? Hold on. Now I'm interested in finding out. Data.world. I've legit never heard of this website. Data.world is uniquely engineered for AI. Data.world is the only data catalog and governance platform powered by a knowledge graph, which means you can connect something something. Apparently, there's 131,000 data sets available. World Bank Open Data. Data.world. No, that's a different thing. Um okay, I'll look at data.world later on. For now, I'm gonna carry on looking. I mean, Kaggle has a bunch of very useful data sets. I'm sure somebody has provided a data set on here. Let's take a look at the columns of this sales data sample. So there's order number, okay, invoice number, quantity ordered, okay. Um, where's the list? Price each, okay. Wait, I need to scroll down. You know what? I can bring it up here. I can probably narrow down the search to just Kaggle, so we can then explore the stuff on Kaggle. Give give me a second and I will bring it up. Sales dataset site kaggle.com. All right. Okay. So they have something here. They have a couple of things here. I've actually gotten a data set off of Kaggle before. Right. So I'm looking for something like this: transaction ID, date, customer ID, gender, age, product, category, quantity, price per unit, and total amount. Okay. Okay. Sales data. Offers so and so, so and so, so and so. Okay. Cool. Cool. E-commerce sales data set. This is great because I'm trying to find patterns in sales data, not specifically like these types of sales data set. Well, no, not this type of sales data. I'm looking for like food sales data, but it can still be applied to that as well. Um, yeah, I don't see how it would be different, at least in terms of like in terms of finding patterns. I don't see how it would be different. Okay, about the data set. Hold up. Okay, yeah, here it is. So order number, quantity ordered, price each, order. Are the column names mentioned? So there was a thing somewhere where you could see just the column names. I remember. I just don't remember where it was. Oh, here. Maybe it's this. 10 out of 25 columns. There's 25 columns of data in this. That's crazy. Holy shit. Okay. Let's take a look at all the data that's there. Hold on. What is this? Maximize view. What does that do? Oh, you know what? That's convenient. That is convenient. What does this do? Hide tree. That is holy shit. I didn't know this was a thing. Okay. That is convenient. That is very convenient. I can probably switch to detail here. All right, price each, order, line number. Okay, I can look at that later. Sales, order date, status, QTR ID. This is saying 10 out of 25 columns. Let's just select all the columns. I want to see which all columns are there. Right, so there's order number. Will this give like a compact list of the columns? Okay. The thing is slowing down a bit. Okay, status, QTR ID, month ID, year ID. Why do they have IDs for that? Okay, product, MSRP, product something. Hold on, I need to be able to see these names, dude. Okay, status, year, MSRP. Hold on. Yeah, product code, customer name, phone, address line, city. Okay, this is all address, 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 and then customer's own name. Okay. All right. So we can get that from this. What about supermarket sales? Right. So let's open this up. This has 17 columns. Dude, at some point, I want to get back into doing the Kaggle stuff as well. This was another thing that I was doing uh, in the past couple of days. Like I was just revisiting this. The thing is, I want to focus on neural networks as much as I can right now. And in the Kaggle thing, it kind of introduces you to it kind of introduces you to ML models, not specifically deep learning. It goes into deep learning later on, which is great because it doesn't just teach you about feed forward neural networks, it actually goes into convolutional neural networks as well. So that's a great thing. I think in terms of, you know what? Okay, we can check this out real quick. We'll look at the tutorial section, but let's just look at this first. So invoice ID, branch, city, customer type. Customer type. Oh, wait. Recorded by members for customers using member card and normal for, oh, okay, so member or non-member. Okay. Product line, unit price, so and so, so and so, so and so. What is the product? Fashion accessories, food and beverage. All right. Okay. How many rows of data do we have? Because it says 131 KB. That's got to be a lot of rows, right? Let me minimize this and see. Where does it mention? It does mention it somewhere. I can't remember where it mentions it. Okay, I'm gonna have to revisit this later on, and it's probably mentioned somewhere here, but like looking all over the place, I'm not really able to find it. Okay, this says sales or no retail sales dataset. Welcome to the retail sales and customer demographics dataset. Oh, okay, this is exactly what I'm looking for. This synthetic dataset has been meticulously crafted to simulate a dynamic retail environment, providing an ideal playground for those eager to sharpen their data analysis skills through exploratory data analysis. That's exactly what I've been looking for. With a focus on retail sales and customer characteristics, this dataset invites you to unravel intricate patterns, draw insights, and gain a deeper understanding of customer behavior. This is exactly what I'm looking for. Right. What's the stuff? What's the stuff here? Transaction ID, date, customer ID, gender, age, product, category. No, product category is the same. Yeah. Okay. So product, fine. Um, quantity, price per unit, and total amount. All right. Okay. Yes, this is, dude. This is exactly what I've been looking for. Hell yeah. And see, this is also one of the reasons why I want to get back into the Kaggle thing. Not specific. So okay, the thing is, I was in this section, the learn section. Okay, um, and here I wanted to go from the very beginning, but like I knew a bunch of the things that like a bunch of the things from the beginning. I already knew them. I still went through those sections anyways. Like for example, intro to programming. I don't need an intro in Python, right? I know Python, and then there's a separate Python section. I did go through them to see if there were like bits of knowledge I could get from them. Maybe there's something that I don't know. And I think I did get like a few small bits here and there, which is fine. Then we got to the interesting part, which was this intro to machine learning. And then here they started teaching about models and dealing with data using pandas, and actually they cover pandas later on as well. Like they go into detail with pandas. Hold on, let me close this and close this. Yeah, they go into detail with pandas, and then they also have this intermediate machine learning, which in which they go into like various things that have to do with the data that's being used for machine learning, whether it's the training data or it's your testing data. They go into various things there, like how, for example, there was a thing on, I don't know if that's like its own section or if it's in this, but there was a thing on feature engineering, like extracting useful features from the data set that you have, because the data set itself that you have, maybe it might not directly contain information that could, or hold on, it contains information, but maybe that information is not in a form where you can directly feed it into whatever model you're trying to use, be it an ML model or some kind of neural network. Maybe it's not in the proper form where you can use it. So you would have to extract features from it that you can use, and then feed those features into your various models. Um, so they go into various different things in this section as well. I wanna go through these sections. Um, the interesting thing is, oh yeah, so this is a feature engineering section. I also need to look into this section, intro to SQL and advanced SQL. I have not touched SQL in probably a decade. Yeah, yeah, more or less a decade. 12 years, I think. it's not that I've forgotten SQL. I just didn't have any use for it because the environments in which I used it, they were mostly corporate environments. I didn't have much. I mean, okay, not just corporate environments, but mostly they were in like, I don't know what to call it. Definitely corporate environments as well, but even just like office kind of environments. So basically, what I'm saying is the projects that I was working on, they didn't really require SQL. So I just kind of moved away from SQL. And the last time I did any SQL stuff, it was with SQL Server. Like this was like way back, way back. So like I don't know if stuff like SQ, I think it's called SQ Lite. I'm not sure, or SQL Lite, and the various other like SQL related things that are available now, that are relatively much easier to get into than SQL Server was back in the day. I haven't really touched any of those frameworks, any of those toolkits or anything. So I wanna get into one of them. I think SQLite was one of them that I was trying to get into. Here, apparently, they're using Google BigQuery. I can look into that as well. That would be something interesting to set up. I feel like because with various projects that I'm working on, I feel like having some kind of like database server or database engine running, it could be helpful. So that way, I'm not constantly writing data to a file and reading data from a file. I could have like an entire database set up. So basically, I want to get back into SQL. The good news is that I know SQL already, at least like the basics. So I would just need to go into. I would need to kind of get like a refresher and then go into the more advanced topics. I remember SQL having stuff like views, for example. I don't know if that stuff is there in like these other SQL toolkits, but I'm sure there's gonna be like various features that I need to learn, various, let's say, tools that can be helpful. So I want to learn all of those things. The good news, what I'm trying to say is the good news is that it's not completely alien to me. Like I at the very least, I know the basics of SQL, so it should be relatively easy for me to, get started with this. And then it gets interesting. Intro to deep learning, uh, where they introduce us to neural networks. I think they also go into convolutional neural networks here, or I think they do that in this section, computer vision. And then there's this time series thing. I think this just uses ML models. Master efficient workflows for cleaning real world messy data. Okay. Explore practical tools to guide the moral design of AI systems. Geospatial analysis, create interactive maps. Okay. Machine learning explainability, extract human understandable insights from any model. And then intro to game AI and reinforcement learning. So these last few chapters, I can I'll see if I want to go through them. But I do want to look into a bunch of these things as well. And something that I wanted to do, but I kind of just forgot that I wanted to do it, was this. I wanted to participate in the competitions that they have on Kaggle, because they have, aside from the more complex high-level competitions. They also have like beginner competitions, and they have some of the older competitions that you can, like for example, this getting started. This is a great example. They have a couple of these. It's not just one. Learn computer vision fundamentals. Oh, this is using the MNIST dataset. So is this just gonna do a feed forward neural network? Hold on. Introduction to techniques like neural networks using classic datasets. Okay. All right. So the intro. Oh shit! I missed the ad timer. Yeah. So there's gonna be an ad playing. Dude, NLP. Yes. NLP was somewhere here as well. I don't remember where it was. I think that was a separate. I think that might have been a separate Kaggle thing, a separate Kaggle course. But yeah, I want to get into NLP. 100%. I want to get into NLP because I want to go towards building language models, and there's a ton of NLP involved in that. Okay. What I was about to say was that so these competitions that they have, you can apply. They basically present you with a problem, and then you have to solve the problem. Like that's my understanding of it. Okay, there's an ad playing, so I'll see you guys in 30 seconds. Okay, welcome back. Dude, there's now that I'm looking at these all of these now that I'm looking at this list, there's a bunch of interesting things. These are oh holy shit, dude. Wait, hold up. I'm glad that they mentioned the what do you call it? The like when the thing was hosted, I guess. This is from like 9 years ago. This is from 10 years ago. This is crazy, dude. Yeah, this is crazy. Um I guess I can stick with the ongoing ones because I feel like those would be the more fresh ones, I guess. Connect your checkers in a row before your opponent. Use GANs to create art. Will you be the next Monet? Okay. Contradictory, my dear Watson. Detecting contradiction and entailment in multilingual text using TPUs. Wait, hold on. Is getting started supposed to be like a difficulty level or is it just a tag? Like, okay, let's take a look at some of the top ones right now. Oh God, this holy shit, the prize for this thing is $1 million. That's crazy. Is there like a difficulty thing that they mention? Child Mind Institute, problematic internet, something, something. Hold on, I need to open that up to read the whole thing. Problematic internet use. Uh, relating physical activity to problematic internet use. I need to look at if there's like a thing that mentions the difficulty level. This competition requires identity verification. That makes sense with a like this. Hold on, what is this? 60,000. That's crazy, dude. Like, okay, you know what's interesting? I don't. Okay, not to say that I couldn't use the money. I could definitely use the money, but like I'm interested in doing and participating in a bunch of these, but I have no interest in the money. Like if that makes sense. I mainly want to do it so that I can learn and like build my knowledge of machine learning and deep learning. Oh, another interesting thing that I want to try out is I want to try applying simple ML models to problems and then try applying neural networks to those problems and see which one works best in which situation, because each of those, like the let's say we're talking about linear regression, for example. Linear regression versus neural networks, that you can apply both of them to a problem, to solve the problem, right? But apparently each of them has its pros and cons. Each of them is strong in certain situations but weak in some other situations. So I want to test that out. That's going to involve me that's going to involve me relearning linear regression, which is also again something that I want to do. Uh, I I already looked into like the theory of linear regression back in the day. Back in the day being like a couple months ago. I just never really got too deep into the practical side of it, so I need to do that. And I can do that easily thanks to scikit-learn. And thanks to scikit-learn, I also learned about another way. Actually, thanks to scikit-learn and Kaggle, I learned that there's another way to do linear regression. You're not limited to just the linear regression model. You can also do you can also do it through decision trees, which was interesting to me because that introduced me to the concept of decision trees, um, which is mentioned here. Where was it? I think decision trees was in this. Yeah. So I'm glad that Kaggle introduced this concept to me, because there was the simple linear regression, which is just a linear model, right? But I feel like this linear regression, which uses this method, uh, OLS, versus the decision tree regression, even these two methods have their pros and cons, which is something that I want to explore. Man, there's so much shit that I want to explore. And then I start branching out, and then I kind of just get lost. But it's cool. It's cool. There's tons of stuff for me to explore. At some point, like I mentioned earlier, I do want to finish these sections, because there was something important here. Oh, random forests. I need to look at that as well. Wait, hold on. They also cover machine learning competitions here. I forgot about that. Model validation. That is something that I need to learn, because I know like nothing about doing that. Basically, it's kind of like profiling the model. um, I want to say benchmarking, but I don't know if benchmarking. Well, benchmarking, right? Benchmarking the model and seeing how well it's performing. I need to learn how to do that as well. Machine learning competitions are a great way to improve your data science skills and measure your progress. In the next exercise, you will create and submit predictions for the house prices competition for Kaggle Learn users. Okay, cool, cool. So this section is definitely important for me to finish reading. I think this whole thing. Oh wait, no. This comes later on. The missing values thing. Is it just like missing values has to do with pandas? Because like that's how you go about handling it. There's a lot of non-numeric data out there. Here's how to use it for machine learning. Oh, dude, I want to learn that. Yes, because this is also like one of the challenges, right? Because a bunch of the methods and a bunch of the models and stuff, they work with numbers. Even when you're talking about labels, the labels are usually associated with numbers. You present the thing in the form of numbers. Any kind of data that you're trying to feed into these models and these methods, these algorithms, you usually feed it in as numbers. And in some cases, it needs to be in a certain scale as well. Um, like some of them require, for example, normalized data. I don't know, I can't give you an example of which one, but some of them, just as an example, they would require normalized data, or they would require data that's not way too big in size. So not like massive numbers, for example. So where was I going with this? Yeah, being able to I guess this basically comes back to feature extraction, right? You're trying to extract features from the data that you can then use to feed into your models. um right, so this section is also going to be important for me to look into. Categorical variables, where was this? That's here. Okay. Uh, Drop categorical. Okay. Hold on. Chill out with the scrolling. Ordinal encoding, one hot encoding. This is a term that I've seen being used, so I'm excited to learn about this. What else is there? Okay, there's also a bunch of like practical stuff. All right, cool, cool. Yeah, dude. At some point in the future, I wanna participate in one of these like bigger challenges as well. Like keeping the money aside, even if there's like no money involved, just like one of the more complex, like solving more complex problems. That's what I'm trying to say. I wanna be able to solve some of the more complex, or at least attempt. I guess I should say that, not solve, because there's a very low chance that I'm going to solve the problems, but I want to be able to attempt it. I want to have at least that base knowledge to be able to attempt to solve the various problems that these competitions are presenting. Derive exoplanet signals from. Oh wow, this is interesting. Hold on. Oh wait, I remember this. No, no, this is something else. This is something else. Yeah, this is something else. This is not the this is not what I was thinking about, but interesting nonetheless. You must predict a mean and uncertainty for each planet ID. An example submission file is included in the data files. You know what else is interesting? I feel like by participating, because there's only so much that I can, there's only so much that these various subsections in the learn section can teach me, or rather, I should say, there's only so much that these sections can cover without the entire section becoming way too cluttered, right? These sections definitely don't cover everything. These are just like basics, like super basic stuff. Even though it says intermediate machine learning, it's still like super basic stuff. Um, I feel like by participating in these various challenges, I'm going to be introduced to various different topics that I can then explore and learn more from. For example, the difference between image domain, time domain, and spectral domain. Like just as an example. I should look for. Okay, hold up, hold up. I just realized something. So these say knowledge. What you have to gain from participating in this competition, what you have to gain is knowledge. Participating in this, I need to find more like these as well. You get swag, and participating in these, you have a chance to win money. Regression of used car prices. Playground Series Season 4. Okay, what does this say? Oh, is this not accepting okay. Wait, what is this expecting? So welcome to so and so. We plan to continue in the spirit of previous playgrounds, providing interesting and approachable data sets for our community to practice their machine learning skills and anticipate a competition each month. Your goal. The goal of this competition is to predict the price of used cars based on various attributes. Oh, that's why they mentioned regression. Okay. Yeah, yeah, that's one of the things that like you could apply different types of regression to. In fact, even when you're learning linear regression, one of the examples that they'll give is predicting house prices based on various attributes, based on historical data, where, how do I say this? Predicting new house prices based on their attributes, given historical historical data. And the historical data has been used to train the model, so it's not like it's not necessarily referencing. Did I say that right? I don't know. The intonation there seems weird. Referencing. Okay, whatever. It's not necessarily referencing the the historical data. However, the linear regression model or whatever model you are using, the model's weights and biases, or well, in this case, it's not weight and bias, it's considered something else. But basically, let's say that the weight and bias have been they've been adjusted based on the historical data. Okay, we were supposed to be doing. Okay, I'm not even complaining. I'm happy that I'm actually looking into this stuff. But yeah, we were supposed to be doing neural network stuff. But I'm glad that I mentioned stats in the title because I guess we are pretty much just exploring Kaggle. Maybe I could change the title. Um, I could change it to SciPy, not SciPy, Scikit-learn. There you go, Scikit-learn and Kaggle things. I think I'll do that. I think you know what? I think I'll do that, and then we'll just carry on exploring this thing and looking at all the competitions and stuff. Give me a second. No, actually, you know what? Um, I might go back to this because yeah, yeah. No, you know what? As fun as it is exploring Kaggle and as tempting as it is, wait, these are so there's a getting started section, there's featured section, there's a community section, research. Let's take a look at research. Fraud detection, earthquake prediction, mechanisms of action prediction. Can you improve the algorithm that classifies drugs based on their biological activity? Cassava leaf disease classification. Okay. Petfinder.my popularity contest. Predict the popularity of shelter pet photos. Wait, what is this? Test your analytics skills by predicting which New York. That is wow. Why is that so hard to say? New York. Okay, predicting which New York Times blog articles will be the most popular. Oh, this is from 9 years ago. Wait, this competition is only open to students of the MIT free online course so and so, the Analytics Edge. Uh okay, where would I be able to wait, do they also give like the solution? Because like you can't submit the thing here, but it says knowledge. Oh, maybe we could look at the best. Where is it? maybe we could look at the submissions and see which one was the best. Okay, let's try the leaderboard. There's private and there's public. I'm not sure what private and public is. The private leaderboard is calculated with approximately 40% of test data. This competition is completed. This leaderboard reflects the final standings. Okay, what is public? This leaderboard is calculated with approximately 60% of the test data. The final result will be based on the other 40%, so the final standings may be different. Which one should I be going for? Okay, I guess something else to keep in mind is that the solution is only provided with like a couple of them. Right, so let's take a look at this. I'm not sure what this score mentions. It says, wait, okay, let's see if this a change in rank from public leaderboard. Okay, let's take a look at their solution. This was my first Kaggle competition. It was fun, exciting, and I gained a lot from our forum discussion. Hold up. Okay, so you can like discuss this stuff in the forums? Wait, that's interesting. Hold wait, I was expecting like a link to their notebook or something. Do we need to submit the code? If yes, where to submit? Uh, all right. Is there something under data? Oh, this is probably the data that you're going to be using. Okay, this is not the right. Okay. We can move on to something else. This is interesting, dude. I wanna visit this at some point later. Wait, is this made up or is this like a real world? Is this like a real world thing? Urgent need to bring the COVID-19 vaccine to mass production. Will require an effect. I, dude, I'm not sure if this is like a made up thing, right? They made up this scenario, or is this like a real world situation where people are actually trying to solve a problem through this kind of a competition? I'm not sure because it's a dude, honestly, it's a valid approach, isn't it? It's a valid approach because I feel like it would put a lot of minds on the problem. It would put a lot of people's brain power, a lot of different people's brain power into solving the problem. No, I think this is a dude. Yeah. Okay. Hold up. To develop models and design rules for RNA degradation, your model will predict likely degradation rates at so and so. Yeah, I still can't tell if I would have to read this whole thing to understand if this is like a made up scenario or if this is a real thing. Like, is it real world data that's being used? And are people trying to solve a real world problem? Or is it just like a made up scenario where, okay, we have this vaccine and we are trying to do this kind of research to figure out this thing about the vaccine? Like, you get what I'm saying? Understanding clouds from satellite images. This was 5 years ago. Dude, this is great because, like, I feel like you could pick any topic and there would be something of your interest. Okay, here's something of my interest. So there's the playground, simulations, and analytics. Playground says fun practice problems. Then you have train bots to navigate something. Oh, that's for like specific situations. Okay. And then analytics. Okay, so let's try analytics. Essays on the state of machine learning in so and so. Wait, are we generating the essays? Okay, making it exceedingly hard to keep up with the current innovations. The goal of this competition is to tap into the diverse expertise of the Kaggle community to centralize and summarize the rapid advancements in AI from the past 2 years. The Kaggle community has a breadth and depth of AI experience which extends beyond the reach of any single individual or research group. We aim to share your collective perspective with the broader research Dude, that's crazy. That's interesting. I'm still curious about this thing, dude. I'll look into this later because I like this idea of taking like a real world problem that requires tons and tons of research and sort of, for lack of a better term, gamifying it, creating a competition out of it where people can come together to try and solve the problem, and the best solution wins something, right? So there's some kind of incentive for people to work towards. But in working towards that incentive, a bunch of people end up putting a lot of brain power into trying to find solutions to the problem. So you end up having a ton of like research and development being done just through the competition. Of course, things get a little bit complicated when there's like private companies involved, because they're not always open to sharing their data. If you know, you get what I'm saying? Uh, is there anything ongoing here? Actually, here it doesn't need to be ongoing. Here it can just be like they'll give you, okay, match career advice questions with professionals in the field. Data science for good. City of Los Angeles. Help the city of Los Angeles to structure and analyze its job descriptions. Okay. Help evaluate help evaluate defensive performance on passing plays. Can you help preserve blue gold using data to predict water availability? Oh, they're calling water blue gold. Okay. All right. What about the other section? So we had playground and simulations. Let's take a look at simulations. All right. Okay. So there's a bunch of like games. Cool, cool. There's probably going to be like a chatbot kind of thing as well. Wait, this is the entire list? Okay, what does this say? Terraform Mars and help test season 2 of. Oh, wait, this is okay, so it just occurred to me. I think they are providing the environment and you have to build agents that can do something in those environments. Let me let me just open this up and see if my guess is correct. This is a competition where competitors design agents to tackle a multivariable optimization, resource gathering, and allocation problem in a 1v1 scenario against other competitors. In addition to optimization, successful agents must be capable of analyzing their opponents and developing appropriate policies to get the upper hand. All code can be found at our GitHub. Okay, yeah, so it's within, so basically it's your agent. You have to develop an agent that can perform within a certain simulation. That's where the simulation part comes in. But either way, this is interesting. What does this say? This is a competition where so and so, so and so, so and so. Okay. In season 2, we are providing a platform to research large scale decision making, uh, benchmarking, reinforcement learning, imitation learning, etc. at scale. There are two modes. There are two modes of scale through which our competition is actively supporting. Of scale through. Okay, I don't know what scale through is, what scale through means in this context, but yeah, okay. The first is, oh, is this what they meant by, man, chill out with the zoom. No, not the zoom. The what is it? The scroll. Chill out with the scroll. Okay. The first is the environment itself. It's a 64 by 64 map with hundreds to thousands of controllable units per team with complex interactions and rules. Okay, as interesting as this is, I feel like this goes into like a whole other thing. I'm not currently trying to get into simulations. I'm still learning the basics, so I feel like I still have a bunch to learn before I can get into something like that. Binary classification with a bank churn dataset. Multi-class multi-class prediction of obesity risk. Bike sharing demand, regression of so and so, regression, classification, regression, binary prediction, classification, don't overfit it. Okay. Uh all right. Okay, okay. Okay. Um right. So, let's get back into PyTorch. So I already know some of the basics of building the neural network, like how you need to create a class, and then in that class you have to define your init and forward methods, and in the init method you have to create like you have to create like a sequential thing within which you can specify your layers and various like activation functions. So let's just revisit that, I guess. Okay. Neural networks comprise of layers slash modules that perform operations on data. The torch.nn namespace, is the music still going? I doubt the music is still going. It usually just interrupts itself. Yeah, there you go. The torch.nn namespace provides all the building blocks you need to build your own neural network. Every module in PyTorch subclass is the nn.module. A neural network is a module itself that consists of other modules, layers. This nested structure allows for building and managing complex architectures easily. In the following sections, we will build a neural network to classify images in the fashion MNIST dataset. All right, so let's do this first. Actually, I mean, the device, I can just set it to CPU. That's fine. We want to be able to train our model on a hardware accelerator like the GPU or MPS if available. Let's check so and so. All right, that's fine. All right. Then comes defining the class. So let's do that. I need to sort of refresh my knowledge um on what on dealing with PyTorch datasets, because the datasets have a specific structure, and when you're trying to pull data from them, there's a specific way to go about doing that. Like when you're trying to pull data out in like mini batches, small batches, there's a way to go about doing that. So I need to kind of refresh my knowledge of that. But other than that, I should be fine. Okay, so let's create a class. Let's say my NN01. Um, all right, we do that and that. And in here, we need to do the flatten thing. So this basically flattens the tensor that you give it, which is kind of it's I'd actually forgotten because I'd used flatten, I think, a while back for something, but that wasn't in PyTorch. That was in NumPy, I think. But it's pretty much the same concept. Like you can take a multi-dimensional array and flatten it into one into a one-dimensional array, or I mean, you're not limited to just that. I think you can control what the final shape is, but like, or I think I don't remember what you control. Hold on, let's. It mentions. Wait, I just remember. I'm glad that I found this out. I think yesterday. This thing where you can just like click on a specific class and it shows you the thing here. Okay, torch dot flatten. Flattens input by reshaping it into a one-dimensional so and so. Oh, okay. So the result has to be a one-dimensional thing. It can take an n-dimensional tensor and flatten it into, or flatten whatever dimension you mention into. Actually, I don't think it's just one dimension. I think it's from a certain dimension. Yeah, I think it's from a certain dimension. Though it mentions here start dim and end dim, so I think you can specify from this dimension to that dimension. It flattens it. Unlike NumPy's flatten, which always copies input's data, this function may return the original object, a view, or copy. If no dimensions are flattened, then the original object input is returned. Otherwise, if input can be viewed as the flattened shape, then the view is returned. Then that view is returned. Finally, only if the input cannot be viewed as the flattened shape in the input's data copied. Okay. Okay. I was only dimensions starting with start dim and ending with end dim are flattened. You know what? We could test it out right now. So we can create a tensor. Let's say T1 equals torch dot tensor, and we can give it multi-dimensional data. Let's give it three-dimensional data so we can then flatten like one of the dimensions. Um, so let's do this and this and this. And then let's have a couple of those. So this is now what? This is three-dimensional, right? Yeah, this is three-dimensional. This is three-dimensional, isn't it? Let's read the shape. Oh, this is not three-dimensional. This is two-dimensional. Oh, yeah. That is my mistake. There. Right. Now it's three-dimensional. Okay, so now we can try that we should have access to the flatten method here, right? Yeah. So the start dimension, if 0 is the first dimension, which is our thing here. So if I just do 0 here, it kind of recursively flattens the entire thing, right? All of the inner dimensions. What if I start with 1? Okay, so then it recursively flattens everything like in each of those. So in that dimension, everything that's in there gets flattened. Doing this would be kind of pointless because that just gives the exact same thing. Okay, now I want, hold on. So let's say I want to start at 0 but end at 1. Okay, that's cool. Yeah, that's what I was wondering. Like can you control what kind of, I mean, that it kind of makes sense, right? That they would add in functionality to control what range of the or which dimensions you want to flatten. Just being limited to one dimension being flattened, it's kind of limiting, right? And it's not gonna, that cannot be applied to all problems. Like not all problems are, how do I say this? It's not going to solve all problems. There's definitely going to be situations where people want to flatten specific dimensions, inner dimensions, not just the outer dimension. Okay, so that solves that. Then in here, we need to define the linear stack. The name doesn't matter. Uh, but I can still say a linear ReLU stack. So here we want to call it sequential. This is where we're going to specify all of our layers and functions. So this is basically where we are defining our neural networks architecture, essentially. So we have a linear thing. I'll enter the numbers later. Then we have, I think it's a ReLU after that. Then we have another thing. Is that it? I think that's it, right? Hold on. Let me tab back into this thing. Oh no, there's another one. Okay. Right, so this takes in 28 by 28. No, okay, hold up. I think they mentioned 28 multiplied by 28 because they kind of flattened they kind of flattened the input before passing it into the network. Yeah, I think they flattened the input. Okay, so there was another function which I need to explore. It was called squeeze. Where is it? Hold on for just a minute. Wait, something is wrong here. What's wrong? Says, oh, okay. Yeah, that solved it. Um, right. What was I gonna do? Yeah, torch. Okay. Let's recreate it, I guess. Or I could do a random thing, right? Rand n or rand in. What's the difference between these two? What does this give? It gives a tensor of what? A sequence of integers defining the shape of the output tensor. Yeah, but what is the data type of this? Returns a tensor filled with random numbers from a normal distribution with a mean 0 and variance 1. Okay. Oh, so it's normalized numbers. It's going to be between 0 and 1. I guess okay, that's fine. I mean, I don't care. Is this supposed to be a tuple? I think it should be a tuple. So let's try this and then let's print it out. Okay. So that is our thing. Now, T1, what was it? Squeeze. All right. Okay. What was it doing? Because I tested this out on something with this kind of a shape. With this kind of a shape. It was actually more this kind of shape. It was like 60,000. It was basically the Fashion Amnist data set, which has like 60,000 images, and those images are all 28 by 28 grayscale images. So it was more along the lines of this. Oh God, why did I do that? Hold on. Let's not do that. Let's also not do this. Let's change this to 3, just so everything can be printed out. Okay. So I need to, I forgot what squeeze does. So I think I had squeeze open somewhere here. Tensor has the function, doesn't it? Yeah, yeah, yeah. Tensor has the function. Uh, Squeeze, there it is. Oh, okay. Torch has it as well. Okay, cool. So this returns a tensor with all specified dimensions of input of, wait, no, back up. Of size 1 removed. Oh yeah, I remember this. I remember reading this and not understanding what this meant in terms of a shape, what exactly this meant. Cuz I would understand. Oh, I think I get it. Oh, okay, okay. So wherever it's Oz, hello, hello. Welcome to the stream. How are you doing, Oz? We are yo, shit. Okay, so in the beginning of the stream, I was supposed to jump into the by the way, Oz, yes. Okay, so this was a while ago. I think 2 weeks ago, maybe, during one of my streams, you were trying to explain to me the thing with the ad timer, and you were saying 5 minutes. For some reason, I was remembering 3 minutes. For some reason, I was thinking that my thing says 3 minutes. It doesn't. You were right. It said 5 minutes. Because I think the next day, or whenever my next stream was after that, when the timer came up, I noticed it said 5 minutes, and I was like, "Holy shit! Okay, that's what she was talking about." Oh, real quick, let me do a thing. Um, Good. I had foods and have tea. Hell yeah, awesome. What did you eat? I'm yet to eat. Um, I think I'll heat up some of my leftover food after the stream. Did I do that right? I think I did that right. Yes. You guys should go follow Oz. Oz is cool people. She does a bunch of things. She does game development. She does art streams and gaming streams, of course, gaming streams as well. Tacos as usual. Hell yeah. Awesome. Hell yeah. So at the beginning of the stream, we were discussing, like, I was supposed to. Yeah, yeah, no problem. No problem. You should. Oh, by the way, there's going to be an ad starting soon, I guess in like 10, 15 seconds, 30 seconds. I don't know how long Twitch is going to take. But we looked into scikit-learn and the various methods that it provides, which I'm going to be using. And then I kind of just geeked out over Kaggle related stuff, Kaggle competitions, because I'm excited to check out the Kaggle competitions. Mostly because they are amazing for practice. All right, there's an ad playing. I'm gonna take a hydration break, and I'll see you guys in 30 seconds. All right, welcome back. So yeah, like I was saying, um, Kaggle competitions. You know what? Okay, it just occurred to me. Kaggle competitions are kind of like game jams. They're like game jams for data science. They're basically game jams for data science because a game jam is more or less a competition. Not necessarily always a competition, but like it's yeah. A lot of times it is a competition. A lot of times people are competing to see who 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 comes up with the better idea or the better game or the better word. There's some kind of prize, right? Um, so I'm excited to get into the various Kaggle competitions that are there. Um, and there's tons of them to choose from as well. Like depending on what, because like in terms of data science and ML and deep learning and stuff, it doesn't all apply to just one topic. There's What is this image? Oh, it's petals. I looked at this and I was super confused. Uh, I like this. Petals to the metal. Flower classification. Hold on, what does that say? Is this a knowledge thing? This is a knowledge thing. Is this using the iris dataset? This competition runs indefinitely with a rolling leaderboard. Yeah, I need to find more of the indefinite competition, or the what do you call them? The the ones that are always ongoing. At least for my like beginner competitions, I want to find all the ones that are doing that are just indefinitely running. Um, oh, that's cool, dude. Twitch's moderation system is getting, or rather, I should say the auto mod system is getting a lot better. Yeah, dude, that's cool. It just caught something, and the thing got restricted as well. So like it didn't show up in the chat, but like it showed up for me because, well, I'm the streamer. But hell yeah, dude, that's awesome. Uh, I didn't see it. I didn't see it at all. Yeah, yeah. That's. I'm glad that it picked it up. So it said that likely harasser. I think it's mainly because this account has probably been going and doing it in like a bunch of other chats as well. It was one of those things where they drop a link and you know what I'm talking about, Oz. Um, it was one of those, but like it just it automatically got caught. Not only did it automatically get caught, but you know how Twitch has this thing where you can set certain accounts to be monitored, or you can restrict certain accounts. This one got automatically restricted, which was that was cool. Twitch Autobot hit the gym, hit the gym and got strong. Yep, yep, definitely. It's gotten a lot better since, um, like let's say 2 years ago, because like things were going crazy. I remember, um, a good friend of mine. I'm a mod on his streams, and like I've been a mod on his streams for like a while. Um, Back in the day, I had to set up Nightbot. I also manage his Nightbot, so I had to set up spam filters for various bot messages because I'd started to notice patterns in the various bot messages that were being dropped. So based on those patterns, I just started adding spam filters into Nightbot. So the whole idea there was that anytime a bot would drop a message and it gets caught, Nightbot would time it out, and then any of the other mods could take their time and ban the person. They wouldn't have to rush with banning the person, and the message also wouldn't stay in chat for too long. So that was a win situation. But like shit was going crazy like 2 3 years ago, and even with the follow bot situation, they've kind of improved with banning various accounts, because this is just what I've noticed with other people's streams, um, which is cool. Anyways, learn how to use tensor processing units on Kaggle. TPUs are powerful hardware, etc. Dude, I need to get a GPU. Um, I need to get a GPU that has TPUs. I don't think my current GPU has them. My current GPU can do CUDA related stuff. Like it can run CUDA programs, so I can offload some of the calculations, but like I don't know if something specifically requires TPUs, I don't know if I'll be able to offload those. I should try and find out, like, because I mean, in PyTorch, you are using tensors, right? So if your GPU doesn't have tensor processing units, let me see, because from what I remember, a lot of the GPUs that were produced in the last 5 years, I think, they have TPUs. Give me a second. Let me Google it. Which NVIDIA GPUs have tensor cores? I'm assuming tensor cores are like the same as TPUs, right? Tensor processing units. Though I think deep down in the architecture, I think I'm gonna have to look at the architecture. That would be interesting to look at. I need to look at the newer um, GPU architectures Fortunately, they put out like they put out the white papers for these architectures, so I can take a look at them whenever I want. I haven't looked at the newer architectures. I'm gonna have to look into those because they include stuff like ray tracing cores and tensor cores and stuff like that. Back in the day, it was mainly just CUDA cores. What was I looking at? Yeah, okay. So, RTX 4000, RTX 5000. Wait, there's 5? Hold on, there's 5. Wait, we we have currently we have what, 4090, I think is the best. I didn't know that a 5000 series had come out. Or was it, is it 3090? I think 4090 is a thing, isn't it? I think that's the thing. I don't know about 5000. But yeah, either way, I need to do research on how exactly offloading the calculation to the GPU works if the GPU doesn't have tensor cores. Like, would it find a way to break down that operation in such a way that it could then be consumed by CUDA cores, or is it just going to use the CPU instead? Oh, also, Kaggle has a GPU thing as well. Like a, how do I say this? I looked into this the last time, and was it Kaggle or was it Hugging Face? I cannot remember at this point. Hold on. I think it was Kaggle, where they had this thing where I'm gonna have to look into it. I don't remember if it was Kaggle or Hugging Face. I think no. Hugging Face has they have like a proper plan for, yeah, okay, so it was Kaggle. I think it was Kaggle. Kaggle has this there was this thing where they were just asking you to be mindful with your usage of the GPU. It was something along those lines because I remember looking for um for payment plans for GPU for, how do I say this? So you can run stuff in the cloud on Kaggle, right? There's different types of like hardware that you can set up usually when you have cloud computing going on. And I was looking for a way to get more GPU power in my specific thing that I had set up. And that's how I found out that they have like, I don't remember what exactly it was. Hold on. Let me look it up. Kaggle GPU pricing, let's say. Weekly maximum GPU usage. That's what it was. Okay. We are implementing a limit on each user's GPU use of 30 hours per something. For context, about 15% of GPU users go over this limit in a typical week. This was a while back. Hold on. I'm gonna open that up here. I know I said we wouldn't go I know I said we would carry on doing the neural network thing, but whatever. We are doing the Kaggle thing as well because I'm excited for Kaggle as well. There's tons of, dude, doing these competitions on Kaggle is going to give me tons of practice in data science and ML stuff and deep learning stuff. Okay. What is it? Kaggle GPU. Running Kaggle kernels with a GPU. Okay. And then there's weekly maximum GPU usage. Right. While that loads, Give me a sec. Okay, so this was posted 6 years ago. And then there was this article as well with Kaggle provides free access to NVIDIA K80 GPUs in kernels. This benchmark shows that enabling a GPU to your kernel results in a 12.5x speed up during training of a deep learning model. Okay. Okay, so with Kaggle related stuff, I was intending on only using PyTorch, even though most of their stuff they're kind of pushing you towards TensorFlow, which is fine. I'm just not looking to do TensorFlow. I'm looking to do PyTorch. So I'm gonna have to see if the notebooks that I create, if they have PyTorch support or not. Because like, oh, actually, I need to see how I would go about installing new packages in the notebooks that I create. Because I'm gonna need a couple of things. First of all, I'll need PyTorch, but I also need stuff like, I mean, NumPy. I think NumPy and Pandas get installed with PyTorch, so that's not a problem. That is assuming I'm able to install PyTorch. So I need PyTorch, I need NumPy, Pandas, scikit-learn. What else? I need matplotlib as well, but like that's more. I'm gonna have to see how the visualization is done because I mostly use Jupyter notebooks. I don't use whatever notebook format they have on Kaggle, so I'm not used to it. I'm gonna have to see how to set up the environment and install packages, and so there has to be a way. There has to be a way to do it. I just need to do the research on it. Okay, let's read this thing because I remember reading this a while back, and this was okay. This was posted by the same person that posted that other thing. Right. So, what does this say? As many of you know, Kaggle gives users free access to GPUs in our notebooks. We wish we could give free compute without any bounds because they help a lot of people do deep learning who otherwise lack access to GPUs. That's me. I mean, I have a GPU, but one that can specifically do tensor related operations. No, I don't have that. Best I can do is CUDA related stuff. Unfortunately, we have a finite budget and we've started hitting our limit. I surveyed a hundred a few hundred heavy GPU users in July, soliciting ideas and information so we can stay within our compute budget while still facilitating your AI exploration. We heard a lot of suggestions. Create fewer competitions, limiting concurrency, limiting access to only certain types of users or use cases, changing our commit workflow, which currently requires a lot of computation to be done twice, and dozens of other suggestions. We worked through the implications of all these. Give me a second. Let me zoom in because it's a little hard to read. Did that zoom in? I think that zoomed in. Okay. We worked through the implications of all these suggestions. After weighing the implications of all these suggestions, here's where we landed. Starting this week, we are implementing a limit on each user's GPU use of 30 hours per week. For context, G, about 15% of GPU users go over this limit in a typical week. That's 4% of all notebook authors. Those users account for 68% of all the GPU use. That's crazy. Most of that use is for workflows we'd like to help with, but we can't continue supporting that level of free compute. We've created this page with some tips to help you get more work done within the fixed weekly GPU budget. And we are working on product improvements that are pure efficiencies, reducing our compute costs while saving you time. The limit on weekly GPU No, the limit on weekly GPU use will be around for the foreseeable future, but we'll try to help you get as much out of it as possible. That's fair. That is fair. And this is also fair. Just let me buy the compute power at a reasonable price with options for the level of power. Though, I mean, I also understand that setting up something like that tends to be a little, it's not the most straightforward thing to do. It would be great. It would be great if they had that, but um, I also understand that it's not the most simple thing to set up. That being said, I would this is definitely, yeah, this is definitely a good suggestion, and I'm guessing a bunch of other people also agree with this. That just give the users the option to pay you to get more compute power. Only turn on the GPU if you plan on using the GPU. GPUs are only helpful if you're using code that takes advantage of GPU accelerated libraries. Example, okay, they mentioned PyTorch here, meaning I should be able to install PyTorch there as well. But most applications don't benefit from a GPU. All right. Actively monitor and manage your GPU usage. Dude, something else that I need to look into is, oh, hold on. Kaggle provides notebook editors with free access to NVIDIA Tesla P100 GPUs. Okay, something else that I need to look into is, what about CPUs? Like, what if you want to upgrade your CPU? Hardware available on Kaggle. What is this? CPU kernel specs. Explore and run machine learning code on Kaggle notebooks. Okay, all right. Kaggle kernel, CPU, and so on. So hardware available on Kaggle. This is 6 months ago. I like that they made a notebook to present the thing. I've taken some time to try and understand what CPU, GPU, and TPU hardware is available on Kaggle. Oh, this is somebody's point of view of it. This is somebody's own interpretation of it based on their tests and stuff. Oh, this is somebody's own observation. That's the word I was looking for. This is someone's own observation. I understand that there's some technical information already available on so and so. I wanted to get the hardware directly from the command line and understand it for myself. Okay, so this is probably not what I'm looking for. I appreciate the work that the person did though, but like that information was probably not what I was looking for. Types of notebooks. Where is the hardware? Is it this? Tech specs. Kaggle notebooks. run in a remote computational environment. We provide the hardware. We provide the hardware. You need only worry about the code. Give me a second. Okay. At the time of writing, each notebook editing session is provided with the following resources: 12 hours of execution time for CPU and GPU notebooks. How old is this? Okay, I don't think it's mentioned. Anyways, um, 12 hours execution time for CPU and GPU notebook sessions and 9 hours for TPU notebook sessions. Wait, they have TPUs separately. Have I been confusing TPUs with tensor cores? I think I have. I think I have. Because I'm starting to remember. A while back I had looked into TPUs, and I think they are like their own separate hardware. I don't know if like new NVIDIA GPUs have TPUs in them. I mean, they have tensor cores in them, but I feel like I've been confusing tensor cores and TPUs because now I'm remembering that TPUs they were their own. Let me just Google this and make sure that I'm remembering right. But I believe TPUs were like their own thing that you can install separately. What is it? Tensor processing unit. Tensor processing unit is an AI accelerator application specific in, it's an ASIC designed by Google for neural network machine learning. Wait, I remember seeing a thing that you could install in consumer PCs. This seems more like something that you would install in one of those what do you call them? Those like big workstation kind of things. Um, Using Google's own TensorFlow software. Google began using TPUs internally in 2015 and in 2018 made them available for third-party use. Both as part of its cloud infrastructure and by offering a smaller version of the chip for sale. Right. What about that smaller version? Because for some reason I remember reading something about TPUs being available for like consumer PCs. I don't know if I'm remembering wrong. But yeah, I think at this point even like Nvidia is probably doing their own thing, their own similar thing as well. Uh I don't know if it's specifically TPUs or not because it says Google's TPUs are proprietary. Some models are commercially available, and on February 12th, 2018, the New York Times reported that Google would allow other companies to buy access to those chips through its cloud computing service. Um, no, Nvidia has been doing something. Hold on. Okay. Um, Google provides third parties access to TPUs through its cloud TPU service as part of the Google Cloud program and through its notebook-based services, Kaggle and Collaboratory. Let me Google this thing. Tensor Processing Unit, NVIDIA. Because I don't know if they are calling it TPUs or not, but NVIDIA did not mention, but like they showcased a thing that could be used for various like AI related computations. I don't remember what it was. NVIDIA, what should I look up? Workstation. I was about to look up workstation thing. There's what was it called? There was a thing. There was a thing. What did NVIDIA showcase, dude? Hold on. Because I'm remembering Dojo, but Dojo is not NVIDIA's thing. Dojo is a product that was being developed, something to do with Elon Musk. Um, he had a company that was working on their own hardware. Like that was called Dojo or Project Dojo or something like that. Okay, let me look this up. NVIDIA, I think it was either 2023 or 2024. I think it was in 2024. NVIDIA. Okay, okay, right. So I think it was the HPC thing. Was that? Hold on. Was it HPC? I'm not sure if it was H. There was. I'm trying to get that model name or that model number. I'm just gonna open up the video real quick. Okay, so right, so there's this cool animation kind of thing that plays. Okay, okay, so they had like their own thing that they were showcasing that you can use to build. Like the whole idea with that was that you could scale it up by getting multiple of that thing, and that way you could set up like an entire like cloud infrastructure kind of thing. Not necessarily cloud, but it was more to do with computing. um I mean, cloud can be a part of that as well, but it was more to do with computing, so you could set up like a massive computing cluster using that. That's what I was remembering from NVIDIA's thing. Now, going back to TPUs. Okay, I'm not gonna obsess over that, at least not right now. I'm gonna look it up off stream, but for now let's carry on reading this. You get 12 hours execution time and 9 hours for TPU. Oh, hold on. 12 hours execution time for notebook sessions, I need to see. Okay, it says each notebook editing session. So basically, anytime I open up that notebook, from that time, I have 12 hours of CPU and GPU usage, and then 9 hours of TPU usage as well. Okay, and then 20 GB uh, disk space, additional scratchpad disk space that will not be saved outside of the current session. Okay, it's a 4-core CPU, or well, 4 CPU cores, 30 GB of RAM, P100 GPU. Okay. No, wait, hold on. What is all this? Why? Wait, no, I'm confused. Why are these extra GPUs being mentioned? So there's CPU specifications, and then there's P100 GPU specifications, and then there's, hold on, T4 X2 GPU specification, and then there's the TPU 1 VM specification. CPU platforms, example Intel Skylake, Broadwell, AMD, may be variable during regular notebook runs. However, submissions runs for code competitions, so and so, are always run on Intel Skylake CPUs. Okay. Oh, okay. Cool. Cool. All right. This is just mentioning like um you have a specific amount of idle time after which it's kind of gonna put the thing in like a dormant mode, and then you would have to kind of restart it again. Okay, you know what? Considering, okay, I'm still confused about this. Like, what this is saying with T4, because it says two NVIDIA T4 GPUs, two NVIDIA Tesla T4 GPUs, but then here it says one NVIDIA Tesla P100 GPU. I don't know if we, like, I don't know if this is up to date or not. So I don't know if we get the option. Okay, what if I try to run somebody's GPU, not somebody's GPU, run somebody's, actually to edit the thing I would need an account. And I think only then I would be able to choose. What if I do this? What if I open it in Google Notebooks? Nope, let's not do that. What if I open it in Collab? Okay, this is going to Google. I was not expecting. I was hoping. Oh, okay. It mentions here GPU P100. So I don't know if, right. I'm gonna have to because like this is a private browser thing that I'm in right now, so I'm not logged into Kaggle here. But like on the other browser, I'm probably logged in, so I can check that and find out. Okay, give me a second. Right, great, awesome. So here's what we're gonna do. Okay, my voice is starting to, you know, get stressed. My vocal cords are starting to get stressed. So I'm gonna end the stream here. Do stick around, cause we're gonna be raiding Little Witch Oz. Oz is cool people. Oz was here earlier, and she's currently streaming some drawing stuff. She's drawing a boop emote and something more. Right. So we're gonna go hang out in Oz's stream. Um, yeah. I'm gonna carry on reading this stuff and more. I'm also gonna go eat something. But yeah, I hope you guys have a nice day, and I will see you all next time. I might do a sculpting stream later on. I don't know. I still have to do my daily sculpting practice. I don't know if I'm gonna do it. I'm kind of tired, so I'll see. But yeah, you guys have a good one. Peace.